Hello everyone, Medical Level Up here, and I'm back again with another video. Today's topic is about a left bundle branch block. This entity is also considered a STEMI equivalent sometimes, but keep in mind that less than 10% of acute myocardial infarctions are actually presenting with left bundle branch block. It's just that you don't want to miss those 10% is why it's considered a STEMI equivalent. So the first condition is going to be the IVCD. Immediately look over to leads V1 and V6. We're going to draw them over here, V1 and V6. So you've got the AV node, the right bundle, but no left bundle here. And we're going to draw the leads to understand how the electrical forces work. So normally in a heart, you would have the septum depolarized from left to right, but since there is no left bundle, the septum is going to depolarize in this condition from right to left, like this. So this current is going to be negative in V1 and positive in V6. So negative deflection V1, positive deflection V6. The next step is the current going into the right ventricle, and the heart realizing that there is no current going into the left ventricle. So this current is detected as positive in V1, negative in V6. So you get a tiny bit of a deflection going back towards the baseline because the RV does not have a lot of muscle for the current to spread. Now towards the end of the cycle, the right bundle throws off a large and delayed current towards the left side, which is negative in V1, positive in V6, and hence the waveform shown here. Essentially, a left bundle branch block can look something like this in V1 and like this in V6. You can see that the vectors are going away from V1 and into the left ventricle towards V6. There are some variations of this. The notch can happen early, the notch can happen late. That's how I wouldn't really ask you to stick to the marrow or the William mnemonic. The next bit is that this could be either a complete left bundle branch block or an incomplete one. An incomplete left bundle branch block is extremely rare and you're unlikely to encounter it. The difference between the two is that a complete one is going to be more than 0.12 seconds and vice versa for the incomplete one. The last thing I need you to note is that there is going to be an axis deviation with left bundle branch block because of two reasons. Number one, the current is mostly directed towards the left side of the heart in order to depolarize the left ventricle. And the second reason is that the last part of the heart to be depolarized is the left ventricle. So you're going to get a left axis deviation with this. So that's essentially a left bundle branch block. Now let's look at this example. You've got IVCD, broad QRS, look at V1 and V6. So you've got a predominantly negative V1 and a predominantly positive V6. If you map it out, it's going more towards the left side. Now you notice that there is no notch in V1. That's why I wouldn't ask you to stick to the William mnemonic for this. Just try to recognize that pattern that the left bundle branch block makes on the ECG. Let's look at if there's some sort of axis deviation over here. So you can see a biphasic complex in AVL, and if we use the 3-lead method or the biphasic lead method, you can tell that the axis is pretty much at 90 degrees to lead AVL. So in this condition, that was pretty much a normal axis. Again, we're going to look at a broad QRS, V1 and V6, pretty much similar to what you'd expect to have in a left bundle branch. V1 is showing a predominantly negative complex with V6 showing a predominantly positive complex, but you can see that there is a Q wave over here. Now in this case there was actually a previous septal infarct which is making the Q wave appear over here. So understand that you can also have variations of a normal left bundle branch block because of previous myocardial infarctions. You see the axis, which is pretty much clear-cut left axis deviation, which supports the diagnosis of a left bundle branch block. Thank you so much for watching. Don't forget to like, share, and subscribe to the channel. As always, feedback and questions are appreciated, and have a good day.